All right, this is going to be our last demonstration. This is number 3. We're going to look at the relationship between temperature and pressure of a gas in my chemistry kitchen. And to demonstrate that, I'm going to make for you one of my most favorite treats of all time, popcorn. And so I'm going to go ahead and put this in, and I'm going to tell you a little bit about what is going on inside of a single little kernel of corn. So what I've done, so this is like an air popper, so I don't have to put any oil or anything into the popper. And so I just put a measure of popcorn in the lid, and I'm going to dump it in and throw it in my microwave. And we can watch the kernels as they pop. All right, cook time. Okay, so while this is actually happening then, I just wanted to say that first of all, corn is my all-time favorite plant, and I get really excited about it. So if you really want to learn more about corn and how like each individual kernel actually forms, please let me know. One of my best friends is married to a farmer in central Illinois, and he farms, I think, 5,000 acres of corn every single year. And so he was telling me how amazing corn actually is. So anyway, what I wanted to show you is this. Inside of one tiny little kernel of corn, you have a lot of water molecules and then also some carbohydrate. And oh, there it goes. And so the temperature is going to affect the water that is found inside of the corn kernel. So you can see it a little bit starting to pop. I wish I could put this phone in the microwave, but I don't think my phone would like that very much. Okay, so I think that you guys get the idea. I don't want you to get so bored and be like, wow, this is as boring as watching paint dry, or you would change that saying to, wow, this is about as boring as watching corn pop. So anyway, that's what's going on inside of my microwave. So as I started to explain, a kernel of corn has a lot of water molecules in it, and so that's what I drew here on my whiteboard. I just have this kernel of corn, and I have some liquid water molecules here. You can tell that they're a liquid because they have 2 little zoomies there. So my liquid water has the little zoomies. And notice that, I mean, you know, a kernel of corn isn't like a water balloon where it's all like sitting at the bottom, but you know, I was just trying to simplify that the diagram for you. And anyway, the water then that's inside of the kernel is going to change. Why? Because when we threw it into the microwave, we increased the temperature. And remember that temperature is going to increase the motion of the molecules and increase the number of collisions, both in frequency and in force. And the water is going to change. It's going to turn into a gas. And that's what's happening in my next picture. My little blue circle with the 3 zoomies is representing a molecule of water in the gaseous state. And notice that in my second picture of my corn kernel, all of my water vapor molecules have spread out. They are moving around very, very quickly, more quickly than they were in my before picture. So let me zoom out so that you can see. So this is my before picture prior to the microwave, and this is while it was in the microwave. And like I mentioned in our previous video, as the molecules increase their speed, they are hitting the sides of my corn kernel with greater speed and greater frequency and greater force, so that eventually it pops. And we get the yummy kernel of corn that we saturate with butter and dump salt all over, and we enjoy whenever we're binge watching a movie or a TV program. And so that is exactly what I have here in my microwave. And as I take the lid off, I've got steam coming out of there, and there is my wonderful little popcorn treat. Now, the white part of it isn't water. The white part is that carbohydrate that I mentioned before, and that's the fluffy white part that we eat. Okay, let's take a look at the temperature-pressure relationship graphically. So, as we saw, by increasing the temperature of the liquid water in order to change it to a gas, by the way, that is an endothermic reaction because the water had to absorb energy in order to move more, to change into a gas, and to spread out. And so remember that it's the collisions between those spreading out water vapor molecules hitting the sides of the popcorn kernel, and that's what's going to increase the temperature. So as the pressure, excuse me. So as temperature went up, the pressure went up. Again, this is a direct relationship because they're changing in the same direction. Because if the temperature goes down, then the pressure goes down. So let's take a look at the graph that I've started over here. Once again, since I changed the temperature of my popcorn kernels by putting it into the microwave, I put my temperature on the x-axis, and then I put pressure on the y-axis. And once again, I don't have anything to measure the actual temperature and pressure, nothing that would like explode in the microwave anyway. And so we're just going to use some qualitative description. So low temperature, high temperature. Well, as the temperature goes up, so let's look at the high portion here. So as the temperature goes up and it's high, what's going to happen to the pressure? Well, look at our relationship. It's going to become high as well. So my dot is going to be way up here in the corner. And since temperature and pressure are going to change in the same direction, as my temperature gets low, so does my pressure. So I'll put my second dot right here. Now remember, the temperature as it goes up, it's going to cause molecules to move around faster and to bounce off each other in the walls of the container, in this case the popcorn kernel, with more force. So yeah, that's going to increase the pressure. And so my line then is going to look like that. There we go. Now, remember when I was also saying that, you know, if you heat a can of spray paint, that it can explode? Well, we see like a mini explosion like that with our popcorn kernels, and it's much safer and tastier as well. But as we increase the temperature, we increase the pressure until the pressure exceeds what the kernel of corn can actually contain, and then pop! We get our delicious treat. Everyone, I hope that you enjoyed the gas demos today. I hope you learned a lot and that you enjoyed the lesson. And thanks for coming back to my chemistry kitchen. Bye.